Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is variables whose value is optional. Before proceeding, make sure that you have already watched these other videos first. Most of the time, the meaning of a variable is the storage of some quantity, but some of the time, your program's logic might be such that there is no semantic meaning for that variable at that particular point in time. Instead, we'd like to be able to express that variable has no value right now. A popular hack is to just use some special value to mean that. For example, we could say that whenever the computer is storing 0 for an integer, we'll assume that means the variable doesn't have any value at that point in time, at least no value that we care about. But this hack doesn't work if at times we do need to recognize 0 as one of the values that the variable might actually have. Another technique pairs our variable with a Boolean. When that Boolean is true, then we're paying attention to the value which our computer is storing in the variable. But when that Boolean is false, our program's logic considers the variable to have no value, and we ignore whatever the computer is actually storing in it. A third technique uses additional indirection. C++17 has a built-in template that implements this technique. This example variable acts kind of like a pointer, so we call it an opt pointer. Where an ordinary pointer variable might have a null value, this opt pointer programs its special null value as nullopt. You are supposed to understand that this null value means that the variable has no value. Other parts of your program can make a has value query to detect this condition. Casting an opt pointer into a Boolean is a shortcut for calling that query function. A default constructed opt pointer is automatically initialized to that null value. Besides just null, you can also give an actual value to an opt pointer, either by assignment or initialization, using either implicit or explicit syntax. Even though an opt pointer is a new form of indirection, you program that assignment or initialization using syntax that's as if the opt pointer were just any ordinary int variable. After an opt pointer has been given an actual value, you could reassign it with some other actual value. Or you could put it back to null, which is what this reset function does. There are 3 ways in which an opt pointer's value could be accessed. Analogous to programming with an ordinary pointer, you could access the value by dereferencing, but only use the dereference operator if you know that it has an actual value, because that's unsafe to do if it might have the null value. An opt pointer's value could also be accessed by calling a function that's named value, This time, it's safe if that opt pointer has the null value. That function will simply throw an exception in that case. A third option is to call a function named value_or. Now instead of throwing an exception, this function indicates the has no value condition by returning back whatever value the client code had passed to it in a parameter. An object's value can be optional. You could first create an object and then have it copy constructed into the storage pointed at by the opt pointer. Or you could use make optional to directly create a compiler temporary with its opt pointer already pointing at a newly constructed object value. When that compiler temporary is used for explicit initialization, there exists an alternative syntax you could use. An optional value can be copy constructed or copy assigned from another optional value. Thus, it could be conveniently passed by value into a function or returned by value from a function. Optional object values can also be copy constructed or copy assigned. For assigning an object value, you could specify your own compiler temporary. Or you could have the system directly create a compiler temporary with its opt pointer already pointing at a newly constructed object value, kind of like what make optional does. In all cases, the left-hand side's prior object value will be properly destructed. If you had been dealing with ordinary indirection via pointers, and you had two such values that you wanted to compare, then you would have needed to dereference both prior to the comparison operator. With two opt pointers, you can still do that same thing. But with opt pointers, you don't need to manually program the dereferencing because the language defines all those usual comparison operators that could be applied to opt pointers themselves, which then automatically does the dereferencing for you.